Good morning, everyone. We're Team 3, Carter's Cause. My name is Theo Smigelski. This is Edda, Jenesis, and Amarisa. And our last member, Hyun, cannot be here today. So the Carter School is a Boston public school in downtown Boston that services students aged 12 to 22 years old. These students have severe disabilities, both mental and physical, and complex health needs. Their mental development is between 1 month to a year and a half. And most students are in wheelchairs, and most students are also pre-linguistic, which means nonverbal. Because of this, physical activity and communication are both emphasized as learning goals at the Carter School. The objective of our project was to create a system that requires students to actively wave a personalized ID card in order to get a personalized response. So our project will encourage students to engage in physical activity every time they enter a classroom. It'll allow them to associate their actions with some type of feedback, and this will allow them to experience cause and effect in their daily routines. This is an overview of most of the hardware components of our project. We use a Raspberry Pi as our main processor with a Wi-Fi dongle to give it wireless communication abilities. We also use a powered speaker to make our announcement and an RFID reader to detect the personal IDs of each student.
So as the Raspberry Pi lead, I needed to be able to program the Raspberry Pi to be able to communicate with the software application that would be installed on the user's computer. And in order to do this, I decided to implement TCP IP communication. And this allows the Raspberry Pi to receive both simple strings as well as larger MP3 files from the user application. And as a part of our requirements, we also needed to be able to communicate with multiple Raspberry Pis. And I decided to create one Raspberry Pi to be the main hub. And that Raspberry Pi then receives all the information directly from the user application and then sends that to the remaining Raspberry Pi nodes. And in order to keep the information organized on the Raspberry Pi, so every MP3 file that the Raspberry Pi receives, the name of those MP3 files are saved in a text file, and they are saved with the corresponding tag string that is associated with that MP3. So when a user taps a tag, the Raspberry Pi receives a string, and because of these text files, it knows which MP3 file to play with which specific string. And also lastly, the Raspberry Pi is connected to several different external devices. It's configured, first of all, with a Wi-Fi dongle, which allows the wireless communication with the user application as well as the other Raspberry Pis. It's also connected, as I mentioned earlier, to an RFID reader. So when the user taps a tag on the RFID reader, the Raspberry Pi, as I said, receives a string. And if this string has already been saved on the Raspberry Pi with an MP3 file, the Raspberry Pi will output that MP3 file to the audio jack, which has a speaker connected to it. And lastly, it's also connected with an LED circuit. It is a simple LED circuit with a green LED and a red LED. So if the user tries to tap a tag that has not been saved, the red LED will blink 3 times, just so they know that it hasn't been saved. And then the green LED lights up when they successfully tap a card and get an announcement.
For our wireless communication, I selected Wi-Fi from a number of different wireless technologies, mainly because of its large range and point-to-hub networking capabilities. Edda selected a standard Wi-Fi adapter that supports the TCP/IP protocol that we use to communicate between our Raspberry Pi and software application. And this adapter is also configurable with our Raspberry Pi, which cuts down on some of the complexity of implementing Wi-Fi. Another kind of drawback of Wi-Fi is the power that it draws, but we are powering our system using a wall outlet, so power is less of a concern.
So for our RFID communications, I selected a low-power, low-frequency USB RFID reader created by Parallax for our project. So with this particular RFID reader, I was able to get successful communication between both the RFID reader and the tags. Also, with a collaborative effort with Amarisa, we were able to have a successful communication between the reader and the Raspberry Pi. In addition to RFID Communications, I was also responsible for creating the design for the cards, which includes our team logo as well as enumeration in the bottom corner so that we can distinguish between all 25 cards.
I'm Eda, and I am the Electronic Devices Manager of Carter's Cause, and I was responsible for picking out the hardware components such as the Wi-Fi dongle and the USB power speaker and making sure that they're compatible with the Raspberry Pi, which is the brains of our project. And I also worked on packaging of all of our components in a custom case to enclose all of our components securely, and I got great assistance from Theo and Jenesis on working on the packages. And I was also responsible for making sure that the audio output from the Raspberry Pi is clear and loud enough for the students at Carter School to be able to understand the announcement and also catch their names from that announcement. And I prototyped the LED circuit, which Amarisa mentioned before, to that circuit reflects the functionality of our working system, and I programmed the Raspberry Pi to control the GPIO pins to turn one green and one red LED on and off, or have them blink 3 times as desired. I was also responsible for powering our entire system, which required power that ranged from 7 watts to 9 watts, including all of our components. And I picked a power supply that's going to provide 10 watts of power from the wall outlet to be able to power all of our components. And we're also using an external power button, as seen on the picture, to be able to turn all components on and off all at once, so we don't have to worry about unplugging or plugging cables, or we don't have to worry about switching the speaker on and off by itself.
So as we said earlier, Hyun, who was our software lead, could not be here today, but he was responsible for developing the software application for our system. So with this software application, he was able to manage both the student and the room names and store them in a text file. He was able to send the MP3 files of both the room and the student's personalized messages to the Raspberry Pi using sockets, primarily operating as a TCP client. And the software application is able to add and remove students as necessary.
And our video is going to demonstrate the use of our UI and how a student would use their tap card. So here we're adding a student, and it's going to show how to add a room function, and then those are added to the list for the user to be able to see them added. Now we're going to add another room function for the second device. And then this shows deleting a student from our database, or from the text file, which stores our data.
So in conclusion, we were able to successfully create an automated announcement system that produces a personalized greeting for the 25 students at the Carter School. Next, we will be installing and configuring all of the systems at the Carter School within the next week. And just a few acknowledgments. We would like to thank Marianne Kopaczynski and the Carter School. Our client is actually not here today. Also David Campbell, Brendan Hathaway, and other students and staff at EPIC. And of course, Professor Pisano and Professor Kia. So again, we are Team 3, Carter's Cause. Thank you.
Was there a lag time, or was I just missing something?
I think what are we showing first? Well, so when you first add a student through the user application, you also need to tap the card so it knows which card you want to associate with that MP3 file. And then it reads the tag again to actually be able to play the announcement. And I don't know if you caught it very well on the video, but each system is for a different room. So the names of the students will be the same, but it's gonna, each one plays a different room. It tells them where they are. And so each system knows like what number it is, so it plays a different room as well.
And then one last question.
Yeah.
How do you manage all the votes or the different Raspberry Pis? Like how can I say like I am in one room and I want to program like 50 rooms of Pis?
Wait, I'm sorry.
So like how do you manage all the different votes? Like you said, there's lots of different rooms.
Yeah, so we currently just have 2 Raspberry Pis in our network, but basically what happens is, like I was mentioning earlier, there's the like hub Raspberry Pi receives information from the user application, and then through a separate socket sends that to the other remaining node. Yeah.
I have a similar question. How scalable is the system? Like, do you know what the limits would be? And how many are you installing, just these 2?
Right, yeah. Right now the plan is just to install the 2. I'm not entirely sure how many you'd be able to add with the way that we did it. The ideal is to be able to continue adding as many as you want, and all you'd have to do is add that with the one Raspberry Pi and not have to touch the software application at all. Yeah.
So I have a question on usability. So if so each student is going to have an RFID card, right? So would they? So I've noticed you have to tap it to the actual detector. But if some students have disabilities and they have to walk through the door, like how close would they have to be? And is it going to be usable in terms of actual real life application and having it reflect?
So one of the actually important parts starting off with the project is that it really is important that they do have to reach to be able to like lift up their tag to that device, because kind of the goal of the project is for them to realize that they have to do this motion. So if it's more exaggerated, yes, so that they can say, hey, I lift up my hand and then I have an announcement and I can cause that to happen. So that's kind of part of the learning goal for the project.
The range of the RFID reader is about 4 inches though, so that's about as close as you have to get for it to.
And if you guys, right now you guys use an index-based system where it's 1, 2, but kind of to go back to the scalability of it, is there a possibility that rather than having it be this is RFID reader 1, this is the RFID reader that's in teacher X's room, like can you actually assign a name to the device as opposed to saying 1? I mean, if I were the system administrator for this and having to remember that 1 is Theo's classroom and number 2 is Amarisa's classroom, just having, rather than using numbers to identify these things, you actually have a name to it.
You can, we put the room numbers, but you can put the name of the, that was kind of just how we showed the demo, but you can put in the name for the
okay, so it doesn't have to be a number, it could be something else.
Yeah.
Yeah, the index only corresponds to the student, so that it allows you to delete it, so you can just enter the index of the student to be deleted, and then that's it.
Good.